can you explain why, or what is constructive mathematics, and why it's not contradictory as this normal mathematics is?
Particular perspective to look on this, and I'm not a mathematician either, so my apologies if I don't explain this right, but the way in which my own understanding of this topic works is there is a difference between the way that mathematics looks traditionally at the space of languages and the evaluation of statements, and the way computer scientists look at them. In mathematics, if you have a specification that uniquely specifies a result, you're pretty much done, and you have because you have discovered the value of a function. And in computer science, you have not discovered the value of a function before you have actually computed it. Right? So what's the return value of a procedure that hasn't been run yet? It's undefined. It's not given yet. We don't know it yet. We have to wait until we get a result. And in mathematics, you can, in principle, leave the calculation to God. You know what this square root of 2 is once you have found a specification for it. And there is a slight problem with that. And I think it became apparent to Pythagoras, who, according to mathematics mythology, got so upset at somebody who blabbed out in public that irrational numbers exist that he punished this man even with death. It's probably not true, but he basically didn't want, apparently, to let the public know about the existence of numbers that cannot be expressed as the result of a fraction between two integers. Right? And if you take a number line, of course, you will find points on that number line in the mathematical sense that are between the fractions. And the square root of -2 and pi and so on are such numbers. And these numbers are the irrational numbers. And the problem with these numbers is that you cannot calculate all of the digits. So in practice, when you take a number line and you, for instance, you take a string and you try to make a knot in it, the position of that knot will always be resolvable down to the smallest atoms on that string to a fraction between integers. Right, so it's the reality is in some sense indistinguishable, but the procedures by which from the rational numbers, but the procedures by which you get to these numbers suggest that you're not always ending up on one. When you basically perform an unbounded number of steps of operations. And you can define an algorithm that is unbounded in the number of steps that you can execute. So you can get an arbitrary number of digits for pi, but you will never get the last digit, right? Because to do this, you would need to run it for infinitely many steps, and that's not possible. You can always, when you are implementing this, run it only for a finite number of steps. And it would be very practical if you had some kind of machine that can run for infinitely many numbers of steps before it gives you a result. But as the halting problem shows, this leads into contradictions.